Hi, I'm Ms. Boom. Let's have a look at dilations and reflections. Dilation from the x-axis. In the last video when we talked about translations, when we translated in horizontally and we talked about x, we changed our x. But when we translated our y, we moved our y. But in dilation and reflection, there's a slight difference. Let's see if you can pick it. Dilation from the x-axis. A dilation of a factor of 2 from the x-axis can be defined by the rule xy, x 2y. Why is that? Let's have a look. Here we have square root of x, for instance. If I want to move, let's say, this point away from the x-axis, so dilation of 2 from the x-axis, so that's the x-axis, away from the x-axis means going that way. So if I go that way, we actually obtain 2 square root of x. How did I get that equation? So we had the xy, and our image will be equal to the original. Our x for this point will be equal to our image is the same for our x value, see there, but our y value, see, it has been multiplied. So it's the y value that gets changed when we are dilating from the x-axis. So let me just recap that. So see that point going from there to there? We are moving we're moving away from the x-axis, so dilation from the x-axis, but the x value doesn't change, it's the y value that changes. So we're going to do what we did before and rearrange this so we get our original x, our original y, and then plug that into the equation. So our new y is now y dash over 2 and equals square root of x, and then moving the 2 over, we can see how we obtain that equation over there. So, and then it makes sense. Dilation of 2 means it's steeper. Dilation in the y-axis. As you can guess, it's going to be the opposite. So dilation in y-axis means x becomes 2x. And we can observe that because, let's say, the point 1, 1 is now going to be away from the y-axis. It's going to go this way, so less steep. So with a dilation less than 1. So let's do the image. So x dash is 2x, y is dy, and when we plug it, when we rearrange and plug it into square root of x, we obtain square root of x dash over 2, which if you take the 2 out of the square root, it's 1 over square root of 2, which is less than 1. So see, less steep, what we expected. So just a quick recap, dilation from the y-axis means you change your x, dilation from the x-axis means you change your y. Example 1. Let's compare both dilations. Determine the rule of the image when y equals 1 over x squared is dilated by a factor of 5 from the x-axis or from the y-axis. We'll do the y-axis right after to compare. So from the x-axis means we're changing the y to 5y. So again, step 1, write down our image. So it hasn't changed, whereas y dash now is 5y. Now rearrange. So x is still x, but y is y dash over 5. And then what do you do after rearrange? You plug it into the original equation. So y dash goes there. And bringing the 5 over, we have y equals 5 over x squared. So when you dilate by a factor of 5 in the x-axis, you get a dilation factor of 5. Remember, previously you've learned dilation of a factor of something from the x-axis. This is the reason. Whereas from the y-axis, it looks completely different. So again, let's write down the image and y equals just y, rearrange, so x equals x dash over 5, rearrange, that doesn't change, plugging this into there, so x dash over 5 where x is, we get that. Now 1 over x squared over 5 squared is the same as 1 over x squared, then the 5 squared goes back to the top. So we get 25 over x squared. If you've forgotten how to divide by a fraction, remember it's just 1 divided by x over 5 is the same as times 5 over x. So times the inverse of it. So we can see that dilation of 5 from the x-axis is what we have been learning and expect, whereas dilation from the y-axis It's a huge different number. Reflection in the x-axis. So how do we make it go down here? Let's have a think about this. We have the 0.11 and now it's the 0.1, -1. So what changed? Was it the x or the y value? The y value. So our xy becomes x minus y. So the y value change. Now putting it into the equation, we have minus y equals square root of x, and then bringing the minus to the outside, we have minus square root of x. So the minus is outside. So reflection in the x-axis, what you're familiar with, what we've done previously. So what do you think we'll do now? Reflection in the y-axis. So here we have square root of x reflecting along the y-axis, means we're going this way. And how do we obtain this equation over here? So the 0.11 is now -11. So what changed? The x or the y? It's the x. See, it's like the opposite that changes. So our image will be minus x and y, and plugging it into the equation y equals square root of x. So putting the negative x in there, we can see why the negative is inside the square root this time, whereas the negative was outside the square root when we were reflecting in the x-axis. And double check, you can check with numbers. If x was 1, for example, that would be a negative number and it wouldn't work, so that's why you don't end up having a graph on that side. But when x is -1, like here, -1 is 1, so we end up with a y value over there. So you can test numbers to convince yourself that it's working, and you can see how we obtain this square root of -x. So you can go back to everything we've done so far about translation, reflection, dilation, and you can see how we obtain it by using this image method of rearranging and then plugging it into the equation. Let's have a compare of the two. Reflection in the x-axis, reflection in the y-axis. The thing you're most familiar with from previous years, and slightly new thing. We can see that the y value changed here, so that's what we did, and plug it into the original equation to get that. And here we can see the x value change, so rearranging and plugging into the original equation, and we get the negative inside the square root. Example 2, determine the rule of the image of a graph y equals x squared when it is dilated by a factor of 2 from the x-axis, reflected in the x-axis, and translated 6 units in the positive direction of the y-axis. Let's try and put all these three things together. So dilated by a factor of 2 from the x-axis, that means our y becomes 2y. And reflected in the x-axis, it means our y becomes negative. But translated 6 units in the positive direction of the y means it's also a y that gets moved 6. So our image looks like that. What's the first step we do after we obtain all this? We rearrange. So let's do that. So x is just x, and then y is going to be, bring the minus 6 over, becomes -6, and then dividing by -2 now becomes y over minus y over 2, and then -6 over -2 is 3. So we have to plug that into there, and x is just x. So let's do that. So the image is plugging that in where y is, and now we rearrange. So bring the 3 over, becomes -3. So multiplying everything by -2, we have -2 and 6, and we can see that we described this previously as translated up 6, I think, and dilated by 2 from the x-axis, and reflected in the x-axis. So this is something we should be looking at and seeing that it's very familiar. But now you know how we come up with that. In summary, a dilation or reflection in the x-axis changes the y value, whereas a dilation or reflection in the y-axis changes the x values. Here, to describe the function y equals f of x, I've left the matching statements together in pairs. I'll leave you to it to read and make sense. You might want to watch this video again because it's a little bit tricky as we move the x and y's around. So recap, if it's dilation reflection, what do? You change the other thing. So reflecting x means changing the y, dilating x means changing the y. Whereas translation, you keep to the same thing you're talking about. So if translating x, you add to x or subtract, and translating y, you add or subtract to y. And then what do you do after that? You rearrange to get x and y by itself. And then the last step is to put it into the original equation and then rearrange to get the new equation. And we've seen that the new equation matches with the description we've been using in previous years. Thank you for watching. I'll see you next time. Bye.